is where that figure's at.
Thank you.
What was it? 836?
836. All right, we're going to start with, we do this two ways. One, I'm going to kind of give you just a general concept whenever you're dealing with cylinders on how to provide the size and locations of them. And these will be the things you always start with, okay, whether it's a negative or a positive cylinder. And then we're going to back out and we're going to look at special cases. Okay? So first off, when we are doing cylinders, keep in mind when I say negative and positive, positive being one that has mass, one that's negative does not have mass, like a hole. Whenever you are dimensioning these, they will require a size and a location. Always locate them in the circular view, both of them, positive and negative. Locate them in the circular view. So in essence, I've got a quick example right here. Here's my circular view. This is a positive cylinder. I locate it in this view because it's our best geometric look at where that object is located. And it doesn't matter if it's positive or negative. You locate it in the circular view. Now, the size information, we switch. Okay? So, positive cylinders. Where do we get a better look at the geometric shape of a positive cylinder? We actually get it in the rectangular view using the limiting elements. We see the full diameter and we see it with object lines. That is where we size positive cylinders. And I threw this quick example out here. It's much more accurate and better line quality in the text, but just kidding. Figure 1741 kind of shows you that also. So when you're looking at this object, this one has both positive and negatives on it. But here's my positive cylinder right here, here, and here. It has been chosen to put the size in this location because here's where I see the real profile of it. And due to grouping, we also get the height of it located. Okay, so we know all the information about it. So here's where I put the size on positive cylinders. Now, it's a rectangular view, right? It's not going to look circular. Make sure you don't forget to put the diameter sign because it is a diameter. So that's the big thing you got to watch for with positive cylinders. Get that diameter sign in there. So, positive cylinders are dimensioned in the rectangular view. Negative cylinders. Here's kind of the statement on negative cylinders. Negative cylinders are sized in the circular view unless shown in section. Then they are sized in the rectangular view. Now keep in mind, this is general concepts with all cylinders. Locate them in the circular view, both of them. Size dimension for positives in the rectangular. Negative cylinders sized in the circular view unless shown in section. And I kind of threw a couple examples out here, although we're going to jump into the text so you can kind of see it. So if I don't pull a section, keep in mind I've got hidden lines for my negative cylinder, almost always. Okay, well, not almost always, always. So I don't dimension the hidden lines. Therefore, I have to put the size dimension in my circular view. Now, if I switch it and do a section, like we're showing down here, now I'm using object lines for the limiting elements. I see a better look at that true diameter. and I'm going to dimension it like a positive cylinder, or I'm going to put the size in the rectangular view. Okay. Notice it's still located in the circular view. So that's kind of the big guidelines right there.
What do you mean by located?
Located. How do I know where the center is so that I can build it? Here's a location dimension. Here's a location dimension. Okay? That's what I mean. Where do they mark the center so they can put that drill bit on it?
11%.
And cylinders are kind of unique in that they always require a location and a size. In many linear features, the size is also a location with it. Now, one thing we're going to look at here in a minute that you really want to pay attention to, many arcs or cylinders are self-locating also. Okay, remember when you've drawn drawings and we've got like a filleted corner, do we have the location of those? No, they come in tangent. Okay, so they self-locate. So that's the only caveat. You got to watch for the ones, if you don't need dimensional information to build it, it's off linear and tangencies, then you don't have to locate it. It's a self-locating curve. And we'll look at examples of that too. Okay, so there's kind of the concept whenever you're looking at these cylinders. Any questions on that? Okay. Let's look at different ways to locate. And oh wait, we had a couple figures. Let me just jump into the text real quick so you can see this stuff as well. Let's go to figure 17.8 that I had listed here, just so you can see these. 17.8. Now here's where they're talking about size and locations, and it's a negative cylinder. So here's the standard way to handle a negative cylinder, where I've got hidden lines showing I can't dimension to those, so I locate, size. That's a negative cylinder. Now let's look at them in section. Let's go to figure 17.17, which is this one. Here you see I've got negative cylinder and then all positive cylinders. So this negative cylinder would normally be done in the circular view. Here we're going to do it in the rectangular view because it is in section. There's actually a little bit better picture of this that's got the multi-view with it, and let's go to that guy. This is on figure 1733 on page 832. It's kind of the same one, but here they're showing staggering. Keep in mind, if I did not run a section on this, okay, every cylinder on here would still be dimensioned in this view except for that one. Now what I would have over in this view then is I would have, if it was not sectioned, I would put that one here and then all the rest over here. Okay? Because I would do a negative cylinder in the circular view. Okay, and this is a cue to our readers also. They see one done in the circular view, they should know that's a negative cylinder. If they see it done in the rectangular view and it's not a section, they should know it's a positive cylinder. Cheryl?
How would you handle a half section with this and the dimensions? You only show it going to the half mark?
No, you would still do it in the circular view if you did a half section.
Or so it goes back to the circle?
Yeah, because keep in mind a half section, let's just say we've got this center line here and then we would show outlines here. So it's going to look something like, I'm just going to kind of estimate the profiles here. Be something like that and there wouldn't be any hatching here. Well, I can't get to this half. I'm not going to do half of a circle. Okay, so I would just go back to this protocol. If you can't do it all the way, stick with the same thing we've talked about.
But you would do those ones there?
Yeah, I can still do those there.
Yeah, except for the dimension.
Mhm. So general consensus, whenever you have a cylinder, always locate them in the circular view. Just locate them. Positive cylinder, put the size dimension in the rectangular view. Negative cylinder, put your size dimension in the circular view, unless you show it in section. Then do it like a positive cylinder. That's a general consensus that'll handle 90% of all of your cylinders. Now, the location of these gets to be something that we gotta really kind of play with. So I kind of want to look at some location examples, and I think this will be a big help to you as far as why we've been doing center lines all along. Here's where center lines are going to save you a ton of work. So let's look at how we locate cylinders, both negative and positive, that sit around objects. So let's go to your handout, because it has much better examples than your text does. And we're going to start with figure 11.37. You see on it's page 310 on your handout. So here's a bunch of negative cylinders about a center. So we've got our little circular center line here. That is a location circle. So this is where these can just save you a lot of work. Now when we're looking at this one, there's 5 of them on here. They're equally spaced. So they've gone and used the multiplier, 5 by 17.4, and then they put equally spaced. Now notice where they've attached the size dimension to. They've attached it to this one. They did that because it's going to locate in your X and Y direction. This center line locates from the center out. So in essence, with some center lines here, we've taken all the locationing out of these holes. They put it on this one because it's on a quadrant location. So therefore, it is self-locating. You know it's going to be on the top quadrant, and it's going to be this far from the center. So that one's located. That guy's going to be placed. Then the rest of them are done by taking 360 divided by 5, and they can figure that out. So in essence, they've got 2 location dimensions on here, and only one of them spec'd out, and it's done. You've located all 5 holes. Yes?
Okay, another dimensioning, we did the radius from the inside and diameter coming from the outside. So now you got the diameter coming on the inside of the circle.
This is in the handout. We'll go. This is still an ANSI approved deal for diameter, but we'll go over that later. Keep in mind, some of the ANSI stuff in this text is not quite right? I told you that yesterday, or when I handed this out. This came from an old text, and it all got switched after this.
But we can find those lines in our
Do that?
text also.
Yeah, I would do, the only change I would make to this for today's standards
Yeah, okay.
is that. That's the only change. I wouldn't put that inside.
Okay, that was my question, I guess.
That's the only change I would make in today's world. So, good way to locate. Now, what you want to do is watch for these cylinders that sit on the quadrant points because they're self-locating. Somebody should be able to draw a circle and figure out where their quadrant points are. Here's another example of one here. So we're doing the 4 by. We've got our circular one, which takes care of from the center out. Okay, that takes care of all that dimension. The other part, if it's on a quadrant, it's self-locating. We do not have to size those. This one's off. This guy's got to be located. And it should be located from a quadrant line. Okay, they've given this angle. This angle right here would work just as well. Either one of them. It's just got to be brought from a quadrant line. These 2 right here are done from here and here. Now this is an angle setup. The exact same thing's going on here, but here they are using X and Y from a quadrant location. So again, we got this same circle that's showing the location from center out. This guy's self-locating. These 2, this one and this one, need to be located from quadrants. Whether you go linear or whether you go angle depends on how the part is going to be built. Remember, we always prefer linear versus angle. So a couple good examples on locating. Let's turn the page. There's 4 or 5 of these. We're not going to go over all of them, but here's another example. Okay, here's a bunch of holes that are a constant distance from a center. That's what that line takes care of right there. Now they're going ahead and saying, well, this guy's on a quadrant location, right? Okay, so he's self-locating. We're going to have this one dimension that would sit right here that's going to locate that one and that one. Then we're going to do angles from there to the other 3, because they are not on quadrant locations. We had a lot of questions. When do I extend these center lines to other holes? This is a great example right here. So they've got this center, it sits horizontally the same as that one and that one. They brought the center line all the way through. What does that do for you? It locates in that dimension, in this case that Y dimension, where all of them sit. So that's your location. Then they only needed width, that one and that one. And for some reason they thought, well, this one's more important. Once I have that, I'm going to come back to here instead of going from center here to center here. Nice example of using center lines to remove dimensions off of them. Again, you see that also right here, where notice these are all sitting on the same y-axis point. That only needs one dimension, and you've located in a y dimension all 4 of those. I would need another one for this one in the y direction, but then in the x, I'm pulling off, they're doing chain dimensioning here. Kind of like how they've switched the arrows around, because we're too small to get everything to fit. Again, on this one, these 2 right here are located with that one. So take those center lines when they lay on the same axis and use them for multiple holes, because that means you only got to put one number for those. So in essence, we're cleaning the drawing up, right, using center lines. Some more good examples. Here, I think there's one more on page 313. Okay, and this one really has to do with radii. Now this figure right, the one on the left here, you have virtually that same figure on figure 1734 on your text and 1735. So I'm going to just talk about them here. So radius. Now here we're doing cylinders, but they're partial cylinders, right? And again, they can be positive, they can be negative, depending on what the case might be. Our preferred way is to have a tick mark on a radius or an arc. We bring the center line or the leader line up, we put our dimensional information inside of that line, arrows on the inside. Now, technically, I would really want this number off of the object, because I want to keep this out of it. But that's going to get that. Now, when you've got this one, and this one, notice there's really no locations for any of those arcs. Why is that?
Self-locating.
You betcha they are. They don't need any locations. They've got this center line right here. That's the only location they have. And then this guy right here, it's tangent to this one, tangent to this one. This one right here is tangent to that one, and that one includes them both. Remember, 131? This guy right here, tangent to that, tangent to that. Don't need to locate them. They are self-locating curves.
As you're drawing, is there a way you know as you're just trucking along where, of course, as you're drawing, you have it all written with your center points and everything. As you're looking at it, how do you determine, oh, this one's one, I can get rid of all that other stuff? I mean, is it just that tangent?
The same way you drew it's the same way it's going to be built in the field. Okay, these folks go through the same stuff in geometry that you do. Okay, so if you built it and you only needed an X dimension, and then it was tangents took care of the others, that should be probably the same way it's dimensioned. This is, I always had a statement that I picture myself when I've got an object and I've dimensioned it, I actually sit down with the drawing once I've printed it and I start looking at each individual line and saying, do I have the information? I picture myself sitting on my little workbench with a chunk of wood and a saw or something, saying I'm going to cut this stuff up. And I look at it and say, okay, how am I going to make that cut? And I start looking through my drawing and say, well, there's the dimension to get to there, there's the dimension to get there. I can locate that, now I can cut it, and I visualize myself just, grinding or whatever the case. And I go through every single feature on the object. And if I get to a feature and I say, I want to build this, I know it's there, but I don't know where it's at here, then I know, oh, I forgot something. Now, that works for people who have kind of built stuff for a while. Many of you are in here, you're a little young, you haven't had a chance to really do that yet, and that doesn't work for you. Okay, so then it's just kind of experience, thinking about it. As you get older and more experienced, you're going to start seeing that stuff.
So as they're building, like say they were building something that looked like that, is it set up so that they do the main circle and then they are able to do an adjustment to get the other, and then as they keep going, is that kind of the way it goes?
No, not really. I mean, this right here, and how we get that? Well, if you were to draw this, what would you need? You would need that line, and then you would offset that to get that edge. You would offset that to get that edge. Okay. Now, other than that, you don't need anything else, because you're just going to pick a spot, and that's going to drive that guy, right? Okay. So we would start right here, probably. Draw a circle back, that's going to give us that center. Then we can build this arc and we can build that arc. Well, we got one more in here, that's this one. We'll talk about this in a second. But that's built off of this guy, right? So just the same process you would go about drawing it. I don't know what else to say about that.
I guess I was just asking that you said that that's the way they build it, and I guess that's the part I'm kind of hung up on is how do they do that to build it?
They draw it.
They draw it right on a piece of,
Oh.
if it's steel, they got a piece of sheet steel sitting there.
Mhm.
They pull out a marker for steel and they start drawing.
Okay.
They redraw this stuff right on it so that then they cut a line to cut along.
All right.
If it's a CNC machine, the CNC machine will basically find a zero and then cut it for you. It doesn't need the lines because it's doing it internal digitally.
Did I miss it, the foreshortened meter, what it means? If you see
No,
that?
we haven't got to it yet. Okay, I'm gonna go to your text on this. Let's go to, I'm on 832, I believe is the one. So when we're talking about these radii, 832. Folks, this is what your radius should be. Remember, any partial curve. Okay, anything that's not a full circle gets radius. What we'd really like to see is a tick mark. Our leader line points to the inside of the curve. The text is inserted inside of this, approximately in the center. That's preferred on everything. Now, we're going to get to situations that doesn't work on everything. If this is on an external, okay, so let's say, how can I represent this? I can represent it here. So this guy's big enough. If I can't get it to where I can't put the radius in here, because it's two reasons. It's on the object, and two, it's a small curve. If you can, still bring that arrowhead right there. Okay, and put it on the inside of the curve. Then just drag it out, and then you're going to put your radius out here. This would be the next preferred on small ones that are external or rounds. If I can't get the arrowhead, it gets even smaller. Because remember, I need an 1/8 inch for the arrowhead, and I need an 1/8 inch for this line, okay, for them to even recognize it. Okay, so that's the smallest we can get. So if it does get smaller than that, then I go to the way they show on the text right here, where I pull the arrow out, okay, and do it like I would do a positive diameter, I guess might be the right way to say that. So this is really showing you how you want them. This one, as we get smaller, they look like this. Now, what happens when we've got a center that is way off the object, like is shown in figure 1735? This guy. What does this mean? Okay. This is actually the radius, but our center is going to fall off the page. Okay. So that center really is going to sit right here. That's where it actually is. Now that's off my page. So what we end up doing is we take one of our axes, just one of them, and we're going to move it. In this case, they took my vertical axis and we slid the thing up to here. Now, how did I know it was right here? Remember, leader lines are radial. This radius, this thing right here, it should point to the center. Okay? That's what that does, even though we don't show this. This angle right here is the same angle as that. So we just slid the thing up so we can get it on the page. We bring this angle, and then we just throw that line in there. The computer has a tool that does this for you automatically. If you're doing it by hand, this is the way you do it. So just keep in mind, these are radial. So that's radial. L there.
How long does that come up?
As much room as I got. There's no set thing on it.
You don't bring it down so far and then, okay.
No, not a bit. If I can also switch it the other, I try and just do one at a time, so I can either go this way or I could go this way. But I just do one of them and bring it onto the page. If it's way off the page, both directions, like a road, it's very common for a road to have a radius of